Hello everyone. Welcome back to Dr. Lou's VCE Science channel. Today, let's learn together about the 2023 chemistry examination. We will focus on questions related to reaction heat, chemical equilibrium, and reaction rates. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Production of biofuels also damages the environment because of degrading land used to grow food and emissions from fuels used in production and transport. So, number 1 is eliminated. Fuel and fossil fuels generate carbon dioxide and water, greenhouse gases. So, number 2 is correct. Only biofuel is renewable. Fossil fuel is not renewable because plants take millions of years to form it. So, number 3 is eliminated. Finally, only B is correct. This question examines the change in equilibrium constants after a transformation of equations. Since the coefficients of equation 2 are 2 times that of equation 1, its equilibrium constant should be raised to the power of 2. Therefore, the correct answer is D. Please note C. The value of C is the same as D, but its units are incorrect because the units of equilibrium constant also should be squared. Yes, both gases are mixtures, not pure. Generally, any fuels are mixtures because it is not necessary to purify fuels. Yes, both gases combust to produce carbon dioxide because they are hydrocarbons. Yes, both gases are fossil fuels because Earth takes millions of years to form them. So, D is the correct answer. This question is how to increase the yield of a chemical reaction. An increase in pressure favors the direct of the lower number of moles. If the product's in higher number of moles, an increase in pressure should decrease the yield of products. So, D is eliminated. A decrease in the activation will accelerate the rate of reaction but does not affect the equilibrium yield. So, C is eliminated. If reactants are added to the system, the concentration of reactants will be increased, equilibrium will move forward, and the yield of products will be increased. However, if the volume of the system is decreased, the concentration of reactants also increases while the concentration of products also increases. If the product is on the side of the larger number of moles, equilibrium will move to the reactant side. Finally, the yield of products is decreased. So, B is not always correct and eliminated. Yes, a higher value for the equilibrium will give a higher yield of products. So, A is always correct. However, the equilibrium constant is only influenced by temperature. So, the equilibrium constant cannot be changed at a constant temperature. The reaction rate is expressed as molarity concentration per second. So, A is correct. Ask the students to compare the uncatalyzed reaction and the catalyzed reaction. In the presence of a catalyst, activation energy is lowered, but delta H and enthalpy of the reactants are not changed, compared with the uncatalyzed reaction. So, only number 1 is correct. When the temperature is increased, the rate of all reactions must be increased no matter how forward or reverse reaction, exothermic or endothermic reaction. So, only C is correct. The combustion heat of coal and efficiency of power are given, and the mass of coal to produce usable energy is asked. First, calculate the total energy of coal released because the usable energy only is part of the total. Then, calculate the mass of coal burnt. Finally, the value of D is correct. Acquire the heat of combustion of propane from the data book and calculate the amount of energy released from propane. The significant number of the final answer is 3 because the significant number of the heat of combustion is 3. A thermochemical equation has 2 facts: balanced chemical equation and enthalpy of equation. The enthalpy of the equation is not equal to the heat of combustion because the heat of combustion is the energy released per mole, and the enthalpy equation is the energy released actually in the equation. If the coefficient of fuel is not 1, the heat of combustion should be timed by this coefficient to get the enthalpy of the reaction. The unit of enthalpy of the reaction is kJ per mole or kJ. Sketch the energy profile for the complete combustion of propane. Combustion is an exothermic reaction, so the enthalpy of products must be lower than that of reactants. Also, a mountain presents the activation energy barrier. Carbon oxide is one of the products of incomplete combustion instead of carbon dioxide. Carbon oxide can be further oxidized to carbon dioxide, so carbon oxide's enthalpy is higher than carbon dioxide, and energy released from incomplete combustion is less than that from incomplete combustion. The volume of the tank is the volume of gases. So, calculate the volume of carbon dioxide. Step 1. Calculate the amount of ethanol in moles. Step 2. Calculate the amount of carbon dioxide in moles by stoichiometry. Step 3. Calculate the volume of carbon dioxide in liter by universal gas equation. Syllogism is a perfect strategy for this question. The major premise, minor premise, and conclusion cover 3 marks. Major premise. The stronger the intermolecular forces between molecules, the higher flash point because more energy is required to break the intermolecular forces. Minor premise. Both ethanol and propane have similar molecular mass, so their dispersion forces are similar strength. However, hydroxyl of ethanol can form hydrogen bonds, and there are no hydrogen bonds between propane molecules. So, the intermolecular forces between ethanol are stronger than that of propane. Conclusion. The flash point of ethanol is higher than that of propane. If 4 marks are awarded, please add the conception of flash point. Ask source of methane. Methane is sourced from fossil or biology, such as coal seam gas and biomass. The equilibrium constant is defined by a quotient, the numerator of which is obtained by multiplying together the equilibrium concentrations of the products, each raised to a power equal to its stoichiometric coefficient in the balanced equation. Using I strategy, we calculate the equilibrium constant. The first row is the mole of reactants and products. In the beginning, there are no carbon dioxide and hydrogen gas in the system, so the initial of them is 0. In equilibrium, the amount of hydrogen is 6 mole. Using stoichiometry, we calculate the change of other molecules in the system. The change of reactants is negative because of the decrease, and the change of products is positive because of the increase. Then, convert the moles of molecules to molarity because the variables in the equilibrium equation are molarity, not mole. Finally, calculate the equilibrium constant. For the same system, the Maxwell-Boltzmann curve in higher temperatures is narrower and taller than that in lower temperatures. Using diagrams is a good idea, but 2 curves are drawn, not one, and temperature best be labeled. There were 8 multiple-choice questions worth 1 point each, totaling 8 marks. There were also 2 short answer questions worth a total of 19 marks in this section covering fuel, equilibrium, and rate of reaction. The overall score for this section is 27 points. With a total possible score of 120 points, the percentage for this section was 22.5% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Chemistry channel.